Hello, everyone. Welcome to our general meetings. We are here, OpenShift Commons. We meet every Wednesday at 12 Eastern Time. And this month, we have amazing schedule here. So today, for example, we are talking about Edge and AI series. We want to introduce the Edge SIG team who meets every other Tuesday, and also our validated pattern SIG teams as well. So the Edge AI team, the Edge SIG team will be starting here in a few minutes. And in 30 minutes, we'll start with the validated patterns. We also have a full schedule for the rest of the month. And also you can access this meeting always using the same link here below, Commons General from Red Hat. And our recordings are also available at Red Hat Commons meetings recording. Every recording about OpenShift Commons, validated patterns, and HSIG are there available for you. So with that, I'm Valentina Rodriguez. I'm a Principal Technical Marketing Manager here at Red Hat. I focus on OpenShift. I work with applications, developers, everything, GitOps, Backstage, a little of virtual machines. And I am here to introduce you to our speakers. So today with us, we have Dwayne, who will be talking about the HSIG and what is the mission. And also we have Anthony and Michael from the validated patterns. As well as we want to introduce this month for the Edge SIG, they are proposing a theme on Edge and AI. So with that, we have Ben Cohen and Myriam Fernandez who will be talking about, and Diego as well. So yeah, I think I finished my introduction. So with that, I will hand it over to Ben, or to Dwayne, sorry.
Um, good afternoon, everyone. It's a great pleasure to have everyone on today. The Edge, the Red Hat OpenShift Commons Edge SIG. We're very happy and very excited for everyone to come and participate with us and to help us learn and grow as a community. And it's been a great pleasure as Diego has presented and done an amazing job. And we look forward to all future presentations and go validated patterns, our cousins. And we're going to make sure we get that down too.
Perfect. Ben?
All right, thanks. Yep, let me just get the screen up here. So, so I'm Ben, and I'm product marketing for OpenShift and MicroShift, but specifically at the edge. So if you've got OpenShift in a cloud, a central data center, a private data center, edge is everything outside of that. So it could be in a city, it could be on a train, a plane, a factory, a store, right? So it's anything that's not in one of those big central data centers. And we got a couple quotes here. I really like Daniel's on the right. It's edge computing is the utilization of compute resources that are not in a data center or cloud. Other locations where some constraints apply. And we can get to the constraints later. But again, just think of edge as outside the data center. So this is what we affectionately call the onion. As you can see, there are a lot of circles, concentric circles, like layers of an onion. And like most of the slides I'm going to be sharing today, you're going to read it from right to left. So right side being the largest, left side being the smallest. In the smallest circles on the right, where it says enterprise, think of that, again, as the public clouds, the private data centers, large buildings with racks and racks of servers sitting next to each other. Standardized too, right? They're all the same. Outside that, where it says near edge, that's where we get to more regional or even city-sized data centers. So these are going to be local to you, not maybe hundreds of miles away, maybe more like tens of miles. And so these, again, you can still have racks. You can see that there's still a couple icons of racks of servers there, but they get smaller to what we would call large clusters. After that, you get to the far edge. The far edge is where things start to get very interesting. So this is going to be further outside. Again, this could be your trains, your boats, your factories, your stores, cars. You can have small clusters there. You can also have single nodes. And then outside that, you can see there where it says sensors and actuators. those are the actual devices themselves. So that would be the robotic arm, the thermostat on the wall, the video camera. But on that line where there's a little red hat in your top left, we're going to talk about everything to the right of that today. Basically everything that connects all those cool things together. At the bottom, we've got those arrows. Just for in general, the actual data from the sensors, telemetry, events, things like that, those flow inward. So all those cool insights that come from the edge go back to the main data center or the cloud. And then the bottom arrow that faces out, things like your code changes, your application updates, ML models, all those things are going to flow outward. So just a general flow of information. So what can you expect to see at the edge? It's always nice to know, besides seeing some icons. So again, starting on the right side, you've got rack mount servers. So these could be small. They could be 1U, 2U. You might have 2 or 3 of them. That's small relative to what you're going to see in a large central cloud or data center. So picture, in your head, maybe something, roughly this size. Getting smaller as we get further out, maybe this is on the factory floor itself, for example, are going to be these smaller form factor machines. And you can see there are a couple here. The ones in orange have heat sinks, so maybe those are fanless and they can work in a very hot or a very dusty environment. And then to the left, we have the smallest ones. These are maybe the most remote, the lowest power. Hey, maybe they run on solar panels. I've left devices and sensors up there crossed out, just so you know, we're talking about all the infrastructure past that, just not the devices and sensors themselves. So now that we know what you can expect things to look like, how do they all work together? So again, we're going to be reading right to left, and this time we're going to be starting at the bottom. So 3 node clusters, you can have them connected back as part of a larger OpenShift or Kubernetes environment, and that will be in the core cloud. But then customers said, you know what, that's great. We want it even smaller. And so now there are 3 node or compact clusters that can run on the near edge. Great, it's smaller. Customers said, hey, we'd like it even smaller. This is great. So remote worker nodes take that same cluster that's running in the near edge, and they move the actual worker functionality out to the far edge. And so you've got this high availability control plane, those are the red servers. And then on the left, you've got that single worker node that's right on site. Customers say, great, can we go even smaller? And so above that single node OpenShift brings both, again, the control and the worker functions into a single node that can be right on site. It can be very small. If you look at the right side of that, it says it only needs 4 cores and 16 gigs of RAM. And I'd be willing to bet that most people here, their laptop is probably overqualified in terms of that. Great. Can we go even smaller? So the smaller you go, the more remote you can go. And that brings us to device edge. And device edge is a great combination of products. So it's got this trusted foundation of RHEL with something called MicroShift running on top. And MicroShift is going to give you the integration with Kubernetes or other OpenShift environments, but really, really small. So again, if you look on the right, it says you can have 2 cores, 2 gigs of RAM. It's incredibly small. And what's great about all of these is that, again, they're all Kubernetes. They can all run together, and you can mix and match. So if you've got places that need high availability, or you've got some extra space, you can run your cluster there. But if you've got something really small, maybe low or no power, unreliable power, no connectivity, low connectivity, you can add in single node, you can add in device edge, and whatever combination that works for you works. So that's what you can expect to see out at the edge. If you want to learn more, feel free to pause and scan one of these QR codes. You can check it out, learn a little bit more. And then, as Valentina mentioned, we are in the middle of an awesome series that Diego's going to talk about a little bit more, AI at the edge. And so you can see our next meeting is going to be on July 16th. And then, again, it's every other week. So July 30th will be the next one. This is where we're talking about AI and OpenShift. And it's a great mix of OpenShift, MicroShift, and OpenShift AI working together from start to finish. So that's it for me. Thanks for learning a little bit about Edge. And I'm going to pass it over to Myriam.
Thank you so much. Let me just start sharing. Okay, can everybody see my screen?
Yes.
Perfect. So thanks everybody for your time. I'm here to talk a little bit about AI for Edge, what is our main motivation, and what do we recommend to customers. So first of all, what we are seeing more and more in the market is that there is a really growing demand for AI solutions. And we are seeing that everybody wants to integrate AI into their lives and into their companies and into their business. But we also see that right now we are in the hype of the technology. So there's a lot of budget and approvals, and people are buying expensive hardware. But there's not really a lot of realization of what to do with AI. So right now we're in the party stage. What it's an actual fact is that 25% of the overall tech spending will be dedicated to AI within the next 12 months. And also another fact is that there are a lot of restrictions around what data can you share in cloud environments, how do you manage to get low latency, how do you bring this AI compute outside of the data center into the edge to be closer to the user. So that's when AI at the edge becomes a relevant topic. What we saw with a lot of the customers that already have a use case and they are already on the path of putting something into production is that, first of all, investments on AI are not cheap. There is a lot of things that you need to plan. Intensive compute tasks require a lot of very specific pieces of hardware and software. So the problem is that all of that investment, you don't see the value or you don't get any value back until the model or the application powered by AI is actually into production. And to the most of the people right now, it's taking them between 7 to 12 months, if not more, to put these models and these AI applications into production. This is already a problem where you cannot get any value out of your investment for a year. But the other problem is that AI is a technology that right now has such a collaboration and innovation ecosystem that it's moving really, really fast. So a year from now, whatever you put into production is probably going to be completely obsolete. So why is it so hard, and how do we help our customers, or how can you overcome these challenges? So first of all, operationalizing AI, it's not trivial. It's a very complex process because it is not, first of all, it's not straightforward. It contains a lot of iterations, and a lot of the success of a model, it's determined by not only the software, but the hardware, the operations, the environment, the devices that you have available. So a lot of different people with different profiles need to collaborate with the skills they have to make an AI project successful. It's not all about developing the model. That's the smallest piece. And now with Gen AI and foundation models, we are acting more like consumers of these technologies. So it's easier to develop a model and just tune it, or take a trained model and just tune it. But we need to find a way to really build solutions with AI. And for that, we need a lot of collaboration between these different personas. And then the other challenge is, as Ben was mentioning, Edge is totally different from the data center or from the cloud. The main difference is that after a lot of painful learnings and experience, we've finally reached a point where we have cloud providers that give us compute, and all we need to build applications on a a service or on a cloud native environment where everything is scalable, everything is uniform, and you only it's homogeneous, and you only have to ask for resources to get them. On the edge, all of this is lost. We currently do not have like edge providers like a commodity. There are a lot of people trying to get into the space, but there are a lot of different slices of edge that you can provide. There are different places you can go. But what we saw talking to different customers was that there are specific characteristics when you move to the edge. The first one is that there are disadvantaged resources. It could be restricted networks that are denied, disconnected, intermittent. There are a lot of restrictions around bandwidth and the cost associated with moving data from the edge location to whatever you want to compute or do inference. There are also a lot of restrictions about latency. So some use cases that we are seeing with AI is, for example, for autonomous vehicles, where if you have a blip or if the latency is bad, you can actually endanger human life. And also, you have disadvantaged resources in the sense of human resources. In a lot of these remote edge locations, there is not IT people that can operate complex solutions. The second challenge is around data. Because AI is all about data and training models, these tend to be data-centric architectures, excuse me, that focus around these sources of data. So how do we apply compute into all of these layers in a way that it's safe, that we respect things like data privacy, data sovereignty? So sorry. And then the last one is also around management. So on cloud computing, we are very used to having a centralized model for management, to have clusters. Oh, so sorry for that. As I was saying, you have clusters that manage all of these different worker nodes inside of their cloud environment where you can scale. For edge locations, you have thousands or hundreds of thousands of locations, and the management tends to be decentralized. You pass some part of the management of the lifecycle of the application itself and of the models to the edge environment itself, because they know all of the complexities around, how heterogeneous the hardware can be, the different conditions of edge, how to install things on very specific hardware for different use cases. So all of that complexity is passed on to whatever you have on the edge location. So how do we overcome those challenges? We think that a way to be able to be successful productizing AI applications at the edge is, first of all, you have to be flexible and open. You have to be able to freely choose and access models that come from the open source and this very innovative ecosystem, but also proprietary solutions. Right now, there are a lot of clear dominance in the AI space that are, closed source solutions. You need also to take advantage of that, and also think that it's not one size fits all, as Ben had in his presentation. There are some elements that you will need to put in the core. There are some elements you will need to put in some layer of the edge core continuum. So you have to be very flexible. So when we were designing the solution, we have in mind that we wanted to build capabilities for AI, like model serving or model monitoring or model training, that were able to be portable along all of these core edge continuum. So our customers could choose the optimal location for each one of these capabilities based on the trade-offs between the constraints they have. One example, we were just talking to a customer. They wanted to do quality inspection on the line of production. And their first idea was to do it right there where the robotic arm was piecing together some complex equipment, and they wanted to do inference in each one, put a camera in each one of these machine pieces, and really quickly detect when there was a defect on some of the assembly of this product. What they quickly realized was that to move, if they didn't use or if they didn't put the analytics on the device, they will have to move it out to the cloud. And the cost of moving all of these feeds of video to the cloud, it was super expensive. So they discarded that solution. And then they also analyzed the cost of having high-end cameras that could support having inference at the edge. And that was also very expensive. So none of their ideas worked. And that's when they realized they also had a server room where they have more powerful servers where they could do inference and just have all of the cameras stream the images to that server room inside of the same factory floor, which was not expensive, and then do the analytics there. And from there, be able to optimize the process of assembling of these pieces. So our customers don't have, and us, we also do not know what is the best location for these capabilities. So we have to give customers the flexibility of try, test, take into account all of the costs associated, and choose the best place for each one of them. This is a little bit of an example of the customer we were talking about. They decided to train the models on the core data center, and there is where they had all of these compute with accelerators available to train the model and have a really good performance on computer vision. And then once the model was trained, they send it to the factory, into the server room on a compact cluster of OpenShift, and they were doing inference there. And the cameras and all these devices were sending the feed to this inference service. The other way that you can overcome the challenge of having to place compute is you also need a platform that it's hybrid, not only in the topology that lets you choose where to place the compute, but also in the sense that lets people in your team contribute to have a successful AI model and contribute with the tools that they like and the tools that make them productive. So you want to be able to put that model into production as fast as possible to start realizing value. And for that, you need to give to the data scientists the tools that they like that probably are based on Python, that are probably a studio that can be visual. But then when you pass on that model that it's already trained to the platform team, maybe the ops engineer, they prefer more command line tools, and the security specialists, they have their own tooling. So you really need a platform that it's not a very specific AI platform or a solution that it's a black box and the team has to learn a new methodology to then take this workload to the edge. You need a platform that allows everybody to use their tools and that has an abstraction layer that gives you all of these AI capabilities in an easier way. The second one, the second challenge, the second point that we recommend to overcome this challenge is to streamline the AI lifecycle. Streamline the process of how you move the models from experimentation, where you train them, to production. And for these, there's nothing better than automate. Anything that you don't automate, we've seen over and over again, it's prone to human error, it's prone to have inconsistencies, to be not efficient. So use all of the tooling available in Red Hat OpenShift and Red Hat OpenShift AI to automate both the inner loop, which is everything that happens when you are gathering your data, when you are doing conducting data analysis, transformation, when you're training the model, you're doing experiments, everything that you need to do to finally get a model that's ready to be promoted to production. And then you have the outer loop. That's when you finally push the model, and then you have to begin all of the to perform all of the steps needed to put that model into production. Review it, build it, deploy it, serve it, monitor it, both the model and the operational performance, to then maybe retrigger the whole loop again. So what we recommend here is to always have this cycle and this life cycle of this model automated. And it doesn't matter if you're using just one solution like Red Hat OpenShift AI, or if you want to leverage out-of-the-box models provided by hyperscalers, or if you already have another MLOps platform in a different environment. The point here is that you automate the way that you move from one loop to the other, and that you do it in a consistent way. One example is, well, if we use, let's say, like in the example of our customer, Red Hat OpenShift AI, well, you can do all of the model training at the core. Once that you have a model that you are happy with and the performance and the predictions, you can push it out to a registry, and that will automatically trigger the pipelines that build and test the model and containerize it. Once the model is containerized, we push that container image into a plain container registry that already has a lot of the tooling to distribute it in these different edge locations. And what happens there is, remember, we decentralize the management of the lifecycle of the model. So the model serving components at the edge are constantly pulling and polling the core location and this container registry to know if there is a new version that they should update. If they find that there is a new version, they will download it, run it, serve it, publish an API, and start making predictions. They will collect also, or they will generate metrics and logs and other observability data that will be sent back to the model monitoring components of Red Hat OpenShift AI. So this cycle needs to be, automated as much as possible. And if, again, you're integrating third-party solutions, you just train the model somewhere else. You push it to a different model registry, but that, again, triggers the pipeline that builds the container image that then gets served at the near edge, and it's monitored continuously to be able to retrigger in an automatic way a retraining or a tuning. If you're using maybe other tools that you already leverage from your live ecosystem, you have to have a platform that has the ability for you to integrate this in one consistent process to have consistent operations. This will really accelerate your ability to put things into production if you have a consistent way to do it that can adapt to the different environments that you have. And finally, the other challenge that the other way that we see to overcome this challenge of operationalizing a model is to really work on acquiring the ability to get changes of all types, not only changes in the model, but changes in the features, in the configuration of your model server, bug fixes, a lot of critical CVEs, experiments, anything you need to be able to put it into production really fast in a safely and sustainable way. And for that, we definitely have seen that the GitOps pattern, it's something that it's already highly adapted because it's very useful, but in edge scenarios, it also solves a lot of the challenges that we talked about at the beginning. So since we have thousands of different model servers spread out in remote locations, when we do GitOps, because the management of the life cycle is on the edge locations, you don't have just one single server controlling or managing thousands of servers. So that avoids having a contention point and avoids having a limit to how much can you scale. The complexity of the AI applications and the complexity that comes when all of these edge environments are so heterogeneous and the hardware is very specific to the use case, you can also solve it by using GitOps, because if you have a controller that is specific for your environment, that controller absorbs all of the complexity of dealing with a very specific hardware that could be 10 years old. But you still have the consistency of how to deliver that software. And then for disconnected operations, again, because this is a pull mode and not a push, whenever the environment is disconnected, it will just continue operating. And whenever the connection is reestablished, well, it will go and query what are the latest updates available, and it will download them and make sure that they are running the environment. With GitOps, you have benefits that also are better for edge scenarios, like a declarative approach. So you have a way to define the desired state of your AI application, and you can be sure that the controller at the edge will make sure that nobody changes that definition through the command line or anything like that. The definition is always one. You have a built-in approval process. You have version control, which is very important, especially if you are deploying different versions of different models to thousands of locations. And you have eventual consistency that can tolerate disconnected environments. So with this, the goal or the dream of every AI solution is to be fully automated and to be event-driven, to have all of these operated automatically through pipelines and without any intervention of IT people, and just iterating over and over through events that trigger the next phase in the model lifecycle. So with that, that's all that I have. If anybody has any questions, please let me know, and I'll be more than happy to talk more.
Thank you, Myriam. So I think with that, I hope many of you are now very interested in Edge and AI intersection of both and what are the benefits. So thank you so much, Myriam and Ben. And yeah, now, Diego, can you do a quick summary about what to expect on your sessions?
Yeah, sure. So, well, thanks for joining today. So I'm Diego Alvarez. I've been working at Red Hat for the last 2 years and a half as a technical marketing manager. And yeah, I've been focused on the Edge portfolio. I've been working with single node OpenShift, Microshift, and other products. When AI started gaining some popularity, we decided to do something together with AI and Edge. And that's when this Computer Vision at the Edge series was born. So basically, we try to combine both areas. And as you can see here on the right side, this is the diagram with the full life cycle of the workload that we follow. So we have two different parts, the data center and the edge. The data center is the piece that we move closer to the edge. So it's a bare metal server that is going to be used to train the model there. So yeah, that's what we covered during the first episode of the Edge SIG meeting. So if you couldn't join, you can watch the recordings later. So basically, we use a system installer to deploy single node OpenShift there, as we cannot have an entire big data center due to the low resources that we usually have at the edge. So that's what we did on June 18. What we did yesterday was installing OpenShift AI on top of it. So apart from the operator and the platform, we also had to set up some infrastructure. We need to provide some storage. And also we had to expose the GPU hardware so it can be later used for the training in the OpenShift AI environment. So that's what we did on the last two episodes. But we are in the middle of the journey. So in the next one, what we are going to do is training the model in OpenShift AI. So basically, we are trying to build a Safari application, an application that is able to detect animals from in a video or in a camera input, and is able to give you some information about the animal that is being located there. So we are going to see how to label this data set, how to train the model, and how to embed it into a container image so it can be pulled from the edge device. And that's the last thing we will do on July 30. We are going to deploy that model on a small edge device. We need a rail there. We are going to install Microshift on top of it. And finally, we are going to deploy the application. So yeah, as I was saying, we're in the middle of the journey. For those who couldn't join, you can check the recordings here. And yeah, hope to see you there in the next ones.
Thank you so much. Okay, so we, yeah, if there are any questions, please join on the Edge SIG. You will have enough time to ask questions and connect with Diego, Ben, and many others. So now, thank you so much, Diego, Ben, Dwayne, and Myriam for this. And now, all the floor is for my friends Michael and Anthony, who will be talking about validated patterns. Such an amazing group that they are meeting every Tuesday as well. It's very important to have patterns. So to be aware not only of the solutions, but the art of the possibility and how you can integrate different technologies. But with that, I gave all the floor to you.
Thanks, Valentina. And we appreciate working with the OpenShift Commons community to further bolster some of our use cases. In the past, we work really well with the Edge team. And as Dwayne said, this is a sibling organization, just another SIG that we have that's going to promote our different architectures and use cases. We specifically focus on validated patterns, but within Red Hat, there are a number of different organizations that we work with, including our portfolio architecture team, solution pattern team, ecosystem solutions. So when Michael and I talk, we'll go through some of the examples, different use cases. But if you have something as you're listening to this recording, feel free to contact us. Feel free to connect with Valentina. We're open to additional speakers because our goal is to promote knowledge and circulate these architectures, because the more we know, the better we can all engage together. This is an open source solution, and the intent is to coordinate and collaborate with each other to get a better solution longer term. Just a little highlight before we get started. With this, our focus has been not just delivering a use case for a use case sake, but to understand the business drivers behind it. As was mentioned on the Edge and the AI side, when you look at individual use cases, you can see where they're solving customers' problems. A customer has an issue or a concern that they want to increase their AI spend at the edge because they're solving the problem of bandwidth or compute power, or a number of different individual scenarios will yield different results. But in taking those use cases, we can expand out and show how to deploy them easily. Our focus is on innovation, proof of concepts, and delivering these use cases to customers using GitOps that was explained earlier. So validated patterns specifically, we focus on those configs as code using GitOps to deliver a self-contained example. It includes multiple services, all open source. Well, typically, the ones that Red Hat produces are going to be focused on OpenShift or RHEL using Ansible. But we also have a number of partners that we're engaging, and we'll have Michael talk about those in a little bit. I'm sorry we didn't introduce ourselves. My name is Anthony Herr. Michael St. Jean will be talking with us in a little bit and focusing on the partner aspect of things. From the pattern side, what we see is if you understand how a use case works and you don't have to go and dig into the technology, it makes it a lot easier to get started with a proof of concept and then build on that over time. Within this initiative, we've built that into a GitOps framework that allows you to deploy a use case that we're testing on a regular basis. We also include those tests on our external webpage, which we'll link to later. So if you're interested, you're welcome to take a look. And the benefit of that is you can see that they're being maintained version over version, that this isn't a static, a single paper document that shows you how it worked 5 years ago. It's actually maintained so that when services are changed or updated, that they continue to work. That the API connections between each one of the services is tested in our CI so that we're not missing something that may have been tested but isn't reflective in this specific use case. And it's great to look at these things and understand that you're not missing something. If you edit the config, you modify small things, you can deploy this relatively quickly and easily. And they're also very modular and can be maintained over time, so that if you do have a config that you want to swap out a component. It isn't the service that you're looking for. You want something that's compatible or comparable, but not that exact one. There, because of the way that Git works, you can very easily modify our patterns to swap in the components that you're looking for and swap out the one that isn't what you're looking for. So it's very helpful in that regard. When we look at the value in general, this is specific to validated patterns. Because we're doing that testing and we're maintaining these patterns over time, what we see is that customers are looking to go faster, to reduce time, to reduce risk, and get set up an environment that they can test, verify that it meets their needs over a period of time, and then expand. So the modularity, the ability to modify things, it's very simple to introduce a very lightweight use case and then build on that to move it into production over time. So this is one of the benefits on the customer side, but we also don't just focus on that. We're looking at partners, we're looking at architects, we're looking at our services partners, our consultants and our GSIs. Everyone has benefits that they can use for this, whether it is that testing aspect or the quick time to market. Trusting a use case can be very difficult, and it's the work that even the GSIs specifically, they do on their own all the time. But if you're having the vendor, or at least an open source community, go through that testing process, you can rely on that and build your services beyond that. Michael, is there something else you'd like to add in this, or something you'd like to focus on?
Yeah, sure. I'm just listening to the first 3 segments today. I thought was really, really interesting, really exciting to me, because a lot of these workloads I see, they end up in patterns, or somewhere we're touching a lot of those workloads, and a lot of the demonstrations are built, right? But yeah, I'll just hit on a few things, I guess. One of the things when we're building out these patterns, the question that we typically ask is, how is this going to be used in the end? We don't want to build things just for the sake of building things, right? And we typically start at a point where we're looking at an actual customer deployment or a proof of concept or something like that, and how can we accelerate that process in the future, right? And so it is very much built on an actual customer use case, number one. And from that perspective, from a solution architect perspective, it helps them to not only be able to up-level their conversation from the architecture, the platform, all of the technology, but putting that into context of a business use case. But it also helps them in the future, if they have to build a POC for a particular customer, they have a starting point. They have a place where they can go and build out 50-60% of that POC, and then add the additional components that they need to evolve that POC. Now, from a partner perspective, from an ISV or hardware partner perspective, I think it gives us a really good opportunity to engage and demonstrate how their products fit into one of these distributed architectures, and make it, more easily deployable over time. That helps their solution architects when they're doing POCs, but it also helps us as we're going out and we're working with some of the delivery partners. So if you're thinking about cloud services providers or regional or global system integrators, this is a great opportunity for them to take a pattern and, similar to the solution architects, take something that's 50-60% of the way there. And if they're focusing on a particular use case that they're going to market for their clients, they have that basic infrastructure that they can build 60%, 70% of the way there, and then build on the additional components for the individual clients. So I think that's where I see a great benefit. And we'll go into a little bit, maybe in the next slide, we'll start to talk a little bit about how partners are using it. And service specifically around GSIs, we do a lot of work with GSIs. We're not going to show you any patterns because that typically has their own intellectual property that they've built into it. but just rest assured, they're taking a lot of the patterns work that we're doing, and they are integrating it into their labs and working with the patterns for their individual customers in the practices. Some of the ones that we have worked with, I'll bring up Portworx. Portworx has been a great partner for us. Pure Storage and Portworx have been great partners for us, specifically on the software-defined storage or the persistent storage layer for Kubernetes, also backup and recovery. But one of the first ones that we did with Portworx is taking the multi-cloud GitOps framework that has a lot of the components that you need to deploy in a on-prem environment, multiple on-prem environments, or extending out to cloud environments as well. And they built in that persistent storage layer to that pattern. We have additional work to do with them. They're actually, I was at Pure Accelerate a couple of weeks ago, and they're looking at actually taking the pattern to do something that's more specific to OpenShift virtualization in the future. Next slide. We'll go into a little bit more of what we're doing with Cisco. And this is an interesting one because this is, kind of building on that last one. This is a multi-partner play. It has Cisco hardware. It has Intel components in it. It also has Pure Storage arrays and Portworx in this particular configuration. And what they did is they used the multi-cloud GitOps pattern to show not only how they can help to deploy OpenShift on a flash stack Cisco validated design, but also to extend that out to a cloud platform. We do a lot of additional work with Cisco. They have a lot of Cisco validated patterns or Cisco validated designs or CVDs. A few that we have right now that I'm tracking are around AI ML ops. That one is done with OpenShift AI, and they have another one that they're doing around generative AI. But this one in particular has to do with multi-cloud deployments. And you can read a little bit more in the blog post that I've linked here. And then the next one I'll talk a little bit more about is around Intel. Intel actually has done a lot of and continues to do a lot of work with us. They've actually funded a lab for validated patterns down in Raleigh. And they have a group of engineers who have been working on accelerated patterns, working mostly around the frameworks that we built, but they're contributing additional patterns as well. So one of the things with Intel is, like, if you look at it from an AI space, right? They do have deep learning modules around Gaudi. They have GPUs. They have their scalable Xeon processors, and then they have additional tools like OpenVINO that allows you to extend your models out to the edge. And we could talk a little bit more about that for probably another hour. But the point being is that, specifically for the Xeon processors, Xeon scalable processors, they have these built-in accelerators that can take advantage of those processors. Now, from an AI space, you might have some things that are running with deep learning processors or GPUs, but those tend to be very expensive, and you want to really be sure of what you're running on those types of processors because of the cost. And then, but then your data center may have loads and loads of 4th and 5th generation scalable Xeon processors in it, and this is one way that we can accelerate through their AMX accelerator some of those patterns for AI type workloads. And so they published 3 different ones, one around OpenShift AI, so accelerating processes for the ML Ops platform. They took one of our AI-focused patterns, the medical diagnostic pattern, and they accelerated. They were able to show within that demo accelerating that pattern and the inferencing that's happening within that pattern. And then they also did one around multi-cloud GitOps, and reason behind that is, not everything and an AI ML space is the ML ops. Some of it just, you're running an AI workload in, pure OpenShift deployment. So they did something around that. They also have other accelerators. So QAT is a quick assist technology accelerator. They built that into multi-cloud GitOps too, and what that really does is encryption and compression acceleration for things like storage and networking. And then around security, they've built some of these software guard extension protected deployments. One around that they're showing around applications, and the other around secrets vaults. Coming soon, they're working with us around a TDX confidential containers deployment. I think the next one we'll see that will actually be deployed is this Gaudi accelerated generative AI, where they take an LLM RAG model and they accelerate that with the deep learning processor. I'll hit quickly on a couple of examples here around the AMX accelerated multi-cloud GitOps. This is where they took a simple demo application and they built on with that, and then they built some additional customization around a node feature discovery. And the next one is just around the multi-cloud, the medical diagnostics, where they were actually showing that quantized model, and then the additional functionality that they built into it. And you can read a little bit more about this in the Intel pattern blog that I posted down below. Next one is around Veeam Kasten. This is coming soon. So we've been working a lot with Veeam Kasten around OpenShift virtualization. Their tagline is secure everywhere, or security everywhere. You can see a little bit more and even run it into some demos, some hands-on labs and things like that if you wanted to get a little bit more information about what's coming. But they're dedicated to building this into a pattern. We have some additional partners that we're working with around patterns, but maybe we can go into a little bit around the roadmap, Anthony, before we have to leave.
Not really much of a roadmap. This is what our current library looks like. So appreciate all your comments on the different partners. We have a ton of interest, and Michael, you know this. Beyond just Intel, we have Nutanix going through and doing testing on their own. So they're taking our CI, which I didn't mention before, is open sourced. We include the tests that we are testing for each of our patterns in the Git repo. So the interop testing can be done by any hardware vendor or any software vendor to include in that. And Nutanix has taken that on their own and has started testing some of the patterns in their environments. So one thing that we, I don't think I have on the page here, but you see the validated patterns.io link at the bottom. On our site, we have a status page which shows you the CI, which shows you the current results for each of the tests that we have going. We're not always perfect and things change. Sometimes it is in the framework that fails. Sometimes it is something within the pattern, but you'll see the good and the bad for all our current status, all our current CI tests on that page. From this side, I know we have about 2 minutes left, and I can feel the energy in the room. So I appreciate everyone and all the questions that you asked in the chat. We'll have to answer those offline. But in this case, you can see the couple of the new patterns are all in bold. Those have happened over the last 2 months. The RAG LLM, a regional resiliency pattern. We have one focused on OpenShift AI, travel ops, which is more service mesh focused, and an edge anomaly detection. These have all come on within the last 2 months. But as you can see at the top, we have a library of 30 patterns, 30 individual use cases on our site. And you're welcome to use them, configure them, modify them. You can fork them off and do what you'd like with them. We have them the way that they are and test them on a daily basis. Some of them are tested more than others. Not all of the sandbox ones are tested. As they're being created, we may do a validation run, but for the most part, things in sandbox are still in process. And with that,
and contribute.
Oh,
and
absolutely.
contribute. It's all open. So
feel free to take what's there and let us know what you're doing and how they can change. I mean, because they are open, like Michael mentioned, you can submit a pull request and make comments, make additions, make changes. We are going through the process right now, and I know we're at time of figuring out how to do variants. So a customer wanting to do one change, we're not going to spin off that pattern into its own pattern. We're going to want to test it every so often with that change, but it's something that the team is working on. So feel free to engage. There's lots of innovation here. External secrets operator with HashiCorp Vault or one of our other vaulting technologies, it's included in the pattern framework. So with all of this, use it.
Yeah, and now to the last slide, since we're at time. Just so everybody knows, we do have a validated pattern SIG call that we host every other Tuesday, 9 a.m. Pacific time, 12 Eastern time, 6 p.m. for our friends in Europe. But please join us there, and we're happy to have discussions. You can also contribute if you have something that's architecture oriented. Doesn't have to be validated patterns per se, but if you want to talk about architecture, reference architecture, solution patterns, any of that, we invite people to come and contribute.
And with that, we'll toss it back over to Valentina to wrap us up.
Yeah, thank you so much. It was fantastic, really. It's such a pleasure having you all here. Looking forward to Tuesday's meetings every Tuesday to hear more about those patterns. I already have some ideas. I'm looking forward to contribute as well. So with that, thanks everyone for attending and participating and asking questions and comments. We really appreciate it. So join us our next meeting. We will be talking about image mode for RHEL. We will have Mark and Matt from Red Hat talking about this very interesting topic. So looking forward to see you all next week. Thank you so much.